decimal numbers, a peek beyond the point. In many real-life situations, measuring in only whole numbers such as 1 centimeter, 2 centimeter, 3 centimeter, etc. is not possible. This is because the objects are not always exactly 2 centimeter or 5 centimeter long. Their measures can fall between two whole numbers. That is where smaller units become important. Rahul's father was trying to fix a toy using a screw, but he was not able to fix it since the screw was not of the right size. He brought another screw and was able to fix the toy this time. The two screws looked the same, but one did not fit. The difference in lengths was small but important. When compared using the scale, the lengths of the screws were: first screw 2 hole 3 by 10 centimeter, second screw 2 hole 8 by 10 centimeter. Rahul realized that the small difference in length could decide whether something works or fails. A tenth part. A tenth means 1 out of 10 equal parts of a whole. If we take 1 unit and divide it into 10 equal parts, each part is 1 by 10 of the unit, read as 1 tenth. Note that 10 tenths equals 10 by 10 equals 1 unit. Sometimes a measurement is not a whole number. For example, the length of a pencil shown in the following figure is 5 whole 3 by 10 units, which can be read as 5 and 3 tenths units. That is 5 into 1 plus 3 whole 1 by 10 units. We have 1 by 10 equals to 10 into 1 by 10, 1 unit. Now, 5 whole 3 by 10 units equals to 5 plus 3 by 10 units equals to 50 by 10 plus 3 by 10 units equals to 53 by 10 units. Thus, the length of 5 whole 3 by 10 units is the same as 53 1/10 units. Addition and subtraction of tenths present along with whole numbers. 1. A kangaroo made 2 jumps. The first jump was 4 whole 7 by 10 meters and the second was 3 whole 8 by 10 meters long. What was the total distance that a kangaroo jumped? Solution. It may use method 2 shown below. 4 whole 7 by 10 plus 3 whole 8 by 10, 7 whole 15 by 10. Now, 7 whole 15 by 10 equals to 8 whole 5 by 10. Therefore, total length of 2 jumps equals 8 whole 5 by 10 meters. 2. A green lizard has a tail 5 whole 3 by 10 centimeter long, where a chameleon has a tail 7 whole 1 by 10 centimeter long. Find the difference between the lengths of their size. Solution. It may be done in the method 2 as shown below. Chameleon's tail is longer than green lizard's tail by 1 whole 8 by 10 centimeters. No, the number of tenths in 7 whole 1 by 10 is less than that in 5 whole 3 by 10. So, we split 1 unit from 7 and convert it into 10 1/10ths. Now, 7 whole 1 by 10 is converted to 6 whole 11 by 10. It has more units and more tenths than 5 whole 3 by 10. We subtract units from units and tenths from tenths to get 1 whole 8 by 10 from the decimal number system. 100 part. Sometimes tenths are not small enough to show exact measurements. For example, let us consider a sheet of paper whose length is 6 whole 7 by 10, that is 6 units and 7 1/10ths. If this sheet is folded in half along its length, then it becomes difficult to find the new length. We know that the length of the folded sheet lies between 3 whole 3 by 10 units and 3 whole 4 by 10 units. But we cannot say about the exact measurements since there are no markings between 3 whole 3 by 10 units and 3 whole 4 by 10 units. Just like we divided into unit into 10 1/10ths, we can divide each 1/10 into 10 parts again. Then 1 unit equals 10 1/10ths, 1 1/10 equals 10 1/100ths, 1 unit equals to 100 1/100ths. Each tiny part is called a 100 part and its length is 1 by 100 of a unit. Clearly, 100 equals to 10 into 1 by 100 equals 1 by 10. That is 100 equals 1/10. Now, we can say that the length of the folded sheet will be 3 whole 3 by 10. 5 whole 100. That is 3 units. And 3 1/10 and 5 100s. Note, the length of the folded sheet 3 whole 3 by 10, 5 by 100 can be denoted in 3 different ways. Because 3 whole 3 by 10, 5 by 100. 3 and 30, 10, 3 tens and 5 hundreds. 3 whole 35 by 100, 3 and 35 hundreds. 335 equals to 335 hundreds. Addition and subtraction of hundreds present along with tens and whole numbers. 1. Find the sum of 7 whole 5 by 100, 4 by 100 and 12 whole 8 by 100, 800. Solution. It can be done method 3 as shown below. Convert both numbers to hundreds and then add. So, if the sum is 20 whole 4 by 10, 2 by 100, between adding the same. Find the difference. 48 whole 7 by 10 minus 22 whole 8 by 10, 4 by 100. Solution. It may solve the questions of the method 2 as shown below. Now, 48 whole 7 by 100 minus 28 xbxc. 47 16 by 100 equals minus 22. 8 by 10 44. 25 8 6 by 10 100. Decimal place value. We have learned so far that whenever we want to measure something more accurately, we divide each part into 10 smaller equal parts. As we divided each unit into 10 1/10s. And then if each 1/10 into 10 100s and so on. Consider the quantity 463 2 by 100, 7 by 100. For the different digits in this quantity, we have the following place value chart. 400s, 400, 6 tens equals 60, 3 ones, 3, 2 tens, 2 by 10, 700, 7 by 100. If yes, why? Because as we move from right to left, the place value digits increase by a factor of 10 in each step. Similarly, from left to right, the place value decrease by a factor of 10 in each step. As we know, the place values of two adjacent digits increased or decreased by a factor of 10. This way of writing numbers is called decimal number system. The decimal point is used as a separator. It identifies the position in the place values where the integers end and the fractional parts begin. The first digit to the right of the decimal point represents the tens digit. The second digit to the right of decimal point represents the hundredths digit. The third digit represents the thousand digit and so on. So the quantity is written by the decimal system as 463.27. In expanded form, this decimal number is written as 4 into 100 plus 6 into 10 plus 3 into 1 plus 2 into 1 by 10 plus 7 into 1 by 100. The number 463.27 is read as 463.27. Note, we do not read as 463.27. 1. For each of the following quantities, place the various digits in a place value table. Prepare a separate table to write these quantities as a decimal number and also in expanded form. 1. 3 tens, 5 ones, 7 tens, 1 hundreds. 2. 2 hundreds, 4 ones, 6 hundreds. 3. 8 4 by 10 hundred. 4. 32 3 5 by 10 hundred. 5. 9 1 6 100. 6. 9 hundreds. 7. 433 tenths. Solution. Place value table. Note. 430 tenths equals 413 by 100 equals 400 plus 10 plus 3 equals 40 plus 1 plus 3 by the 10 equals 41 whole 3 by 10. 2. Convert each of the following into decimal. Solution. 1. 21 by 10 equals 20 plus 1 equals 2 plus 1 equals 2.01 equals 21. 2. 34 equals to 345 plus 345 equals to 3.45. 3. 4 by 5 equals to 4 into 2 by 5 into 2 equals 8 by 10 equals 0.8. 4. 17 by 25 equals 17 into 4 is 68, 68, 68 equals 0.6 plus 0.08 equals 0.68. 5. 734 equals 734 equals 734 equals 775 equals 7 plus 0 plus 7 plus 0 plus 5 equals 7.75. Units for measurement of length. The most commonly used standard unit for measurement of length is meter, denoted by m. All the other Eigenmann units will be have measurement of length are given in the following table. Conversion of units of length. When we move n steps to the right in the above table, we multiply it by 10 n times. When we move n steps to the left in the above table, we divide it by 10 n times. 1. Convert the following into centimeters. Solution. We know that 1 millimeter equals 1 by 10 centimeter. 1. 7 millimeter equals to 7 by 10 centimeter equals 0.7 centimeter. 2. 3045 centimeter equals 345 by 10 centimeter equals to 345 centimeter equals 3.45 centimeter. 2. Convert 352 to centimeter. Solution. We know that 1 meter equals 100 centimeter. Therefore, 3.52 meter equals to 352 into 100 centimeter equals to 352 centimeter. Units for measurement of weight. The most commonly used standard unit of the measurement of weight length is gram, denoted by G. All the other standard units for the measurement of weight are given in the following table. Conversion of the units of weight. When we move n steps to the right in the above table, we multiply by 10 n times. When we move n steps to the left in the above table, we divide it by 10 n times. 3. Convert the following into kilograms. Solution. 1 g equals to 1 by 1000 g equals 1 by 100 kg. 2. 150 kg equals to 15 by 100 kg equals to 10 by सात्विक तू क्या कर 218 kg equals to 288 by 100 466 g equals to yeah. What? Convert the following to fill in the blanks. Solution. 205 g equals to 5 kg. हाँ. 36 kg equals to 76 by 1000 kg equals to 70 plus 6 equals to 0.076 kg. 3. 0.74 equals to 740 g. 4. 380 g equals to 3800 g. Money. Rupee and paise. The official currency of India is rupee. Each rupee is subdivided into 100 paise. Singular for paise is paisa. Earlier we used coins in denominations of 1 paisa. 2 paise, 3 paise, 5 paise, 10 paise, 20 paise, 25 paise and 50 paise. But 2011 onwards, all coins of 25 paise and less were removed. In present days, The denominations of notes used are 1 rupees, 2 rupees, 5 rupees, 10 rupees, 20 rupees, 50 rupees, 100 rupees, 200 rupees and 500 rupees. 2. Convert each of the following into rupees using decimals. Solution. 1. 550 paise equals to 50 rupee equals to 0.5 rupee. 2. 2 rupees 71 paise 2 rupees 71 paise equals 2.71 rupees. 3. 4 paise equals 4 by 100 rupee equals 0.40 rupee. 4. 3.6 rupee equals 3.60 rupee. 4. Convert from paise to rupees. Solution. 1. 10p equals 10 by 100 rupee equals 1 by 10 rupee equals 1 rupee. 2. 6p equals 0160 rupee equals 0.06 rupee. 3. 99 paise equals 99 by 100 rupee equals 99 rupee. 4. 260p equals 260 by 100 rupee equals 200 by 100 plus 60 by 100 rupee equals 2 plus 06 rupees equals 2.6 rupees. 5. 3 204p equals 324 by 100 rupees equals 300 by 100 plus 20 by 100 plus 4 by 100 rupees equals 3 plus 2 by 100 plus 4 by 100 rupees equals 3 plus 0.2 plus 0.4 rupees equals 3.24 rupees. 7. Convert each of the following into paise. Solution. 1. 4 rupees 5 paise equals 4 into 100 paise plus 5 paise equals 400 paise plus 5 paise equals 405 paise. 2. 70 rupees 7 paise equals 70 into 100 paise plus 7 paise equals 7000 paise equals 7 paise equals 7007 paise. 8. Convert Ru plus P to fill in the blanks. Solution. 2p equals 204 rupees equals 0.20 rupees. 2. 0.03 rupees equals 0.03 into 100 rupee equals 3 paise. 3. 88p equals rupees 88 by 100 equals 88 rupees. 4. 0.40 rupees equals 0.40 into 100p equals 0.40p. 5. 360p equals 360 by 100 rupee equals 300 by 100 plus 60 by 100 rupee equals 3 plus 0.60 rupee equals 3.60 rupee. 6. 0.27 rupee equals 0.27 into 100p equals 27 pound. Locating a decimal number on a number line. 1. To locate a decimal number on the number line, follow the given steps. 1. Draw a number line having marks 1, 2, 3. 2. Divide the space between 2 and 3 into 10 equal parts. Since we are working with tens, mark them 2.1, 2.2, 2.9, 3. 3. Count 7 parts beginning from 21. This point is 2.7. Mark it on the number line. 2. Now, suppose we had to locate the decimal number 2.73 on the number line. We follow the steps given below. 1. We divide a space between 2.7 and 2.8, shown in 1, further into 10 equal parts. Since we are working with hundreds, mark then 2.71, 2.72, 2.79, 2.8. 2. Count 3 parts beginning for 2.71. This point is 2.73. Mark it on a number line. 3. Further, let us locate the decimal number 2.736 on the number line. We follow the steps given below. 1. We divide the space between 2.73 and 2.74 further into 10 equal parts. Since we are working with thousands, mark with 2.731, 2.72, 2.79 and 2.74. 2. Count 6 parts beginning from 2.71. This point is 2.76. Mark it on a number line. 1. In each of the following cases, find the decimal number at the location marked as X. Solution. 1. Number line between 5 and 10. That is, a distance of 10 minus 5 equals 5 units is divided into 10 equal parts. So, each part represents 0.5 units. Now, X is 7 parts to the right of 5. So, X is equal to 5 plus 7 into 0.5 equals 5 plus 35 equals 85. 2. The number line between 6.3 and 6.8. That is, a distance of 6.8 minus 6.3 equals 0.5 units is divided into 10 equal parts. So, each part represents 0.5 by 10 equals 0.5 units. Now, X is 3 parts to the right of 6.3. So, X is equal to 6.3 plus 3 into 0.05 equals 6.3 plus 0.15 equals 6.45. 3. The number line between 4 and 4.1, that is, a distance of 4.1 minus 4 equals 0.1 units divided into 10 equal parts. So, each part represents equals 0.1 by 10 equals 0.01 units. Now, X is 1 part to the right of 4. So, X equals 4 plus 1 into 0.01 equals 4 plus 0.01 equals 4.01. 4. The number line between 7.2 and 7.7, that is, a distance from 7.7 minus 7.2 equals 0.5 units, is divided into 10 equal parts. So, each part represents 0.05 units. Now, X is 4 equal parts to the right of 7.2. So, X equals 7.2 plus 0.4 plus 5 equals 0.74. Comparison of two decimal numbers. Which is larger, 14.025 or 14.03? Solution. The two decimal numbers have the same whole number parts, that is 40. So, we compare the tens digits. Both have the same tens digits, that is 0. So, we can compare their hundreds digits. The first number has 2, while the second number has 3 at the hundreds place. Since 2 lesser 3, we have 14.025 lesser 14.03. Closest decimals. Consider the decimal numbers 2.429, 2.495, 2.5 and 2.59. We have now identified the number that is closest to 2.5. Arranging these numbers in an increasing order, we get 2.49 lesser 2.498, 2.5, 2.59. Among the numbers in the 2.498 is 2 by 100 away from 2.5, whereas 2.59 is 9 by 100 away from 2.5. Therefore, 2.498 is closer to 2.5. 3. Using the decimals 41825. Exactly once fill in the boxes with each of the symbols following to get the decimal number as close as possible to 20. Solution. 1. We fill the two boxes in the whole number part with 2 and it is respectively, and in the 3 boxes in the decimal part remaining, this is 1 and 4 and 5 in an increasing order so that the decimal part has only spread. 2. We fill the greatest among the given digits, that is 8 in the box of the whole number part and the 4 boxes of the decimal part with remaining 4 digits 5, 4, 2 in decreasing order so that the decimal part has maximum value. 3. Starting from the first box, boxes are to be filled with the given digits in an increasing order. Addition and subtraction of decimals. Addition of decimals. 1. Convert the given decimals into lakh decimals. by affixing one number of zeros to the right. 2. Arrange all the endings in the column form such that the decimal points of all these numbers are in the same column and the digits having the same place in the same column. 3. Add column wise. 4. In the sum, place the decimal point directly under the decimal points on the addends. 4. Add 14.72 and 25.418. Solution. We first convert the given decimals into like decimals. We have 14.720 and 25.418 as the two addends. Now we write in the column form and then add. Hence 14.72 plus 25.418 equals 14.138. Subtraction of decimals. 1. Convert the given decimals into like decimals by affixing required number of zeros. On the right. 2. Arrange the two numbers in the column form. Smaller number under the larger one. The decimal points of the two numbers in the same column and the digits having the same place in the same column. 3. Subtract column wise as we subtract the whole numbers fall. In the difference, place the decimal point directly under the decimal points of the given numbers. 5. Subtract 93.725 from 146.37. Solution. We first convert the given decimals into like decimals. We have 93.728 and 143.370 as the two numbers. Now we write them in the column form and then subtract. Hence 146.37 minus 93.728 equals 52.642.